Okay guys, Mr. Mind back with a quick video on 9-2 translations and 9-3 rotations. For section 9-2, we will do one example because the section is very quick. And for 9-3, we will talk about rotating things either 90 degrees, 180 degrees, or 270 degrees. All right, so first we're going to draw a triangle. Like, we get that coordinate. We have that coordinate, and maybe we have that coordinate. And so give me a moment while I connect these. We get that, that, and that. You know what? So we get A, B, and C. So when we talk about a translation, we're going to use what we call a translation vector. A translation vector looks something like this. And inside it's like an ordered pair, except we put in, we still put in numbers. It's just in pointed braces instead of parentheses. So say we put into this translation vector 2 and 3. What this is going to mean is that the x coordinate moves 2 to the right, and the y coordinate moves 3 up. So when we move A would move over 1, 2, 3. Oh, A would move over 1, 2, and up 1, 2, 3. So this coordinate would become A prime. If we move B, B will move over 1, 2, and up 1, 2, 3. So this coordinate becomes B prime. And when we move coordinate C, C will move over 1, 2, and up 1, 2, 3, and we get C prime. So I'm going to use a different color just so it's not terribly confusing. So when we draw this, we get this figure. And so you can see every coordinate has been shifted 2 to the right and 3 up. The other way we can do this without actually having to draw this is just add these values to the coordinates. For A, its original coordinate is 1, 1. For A prime, if you note, its new coordinate is over 3, up 1, 2, 3, 4, is 3, 4. We would have gotten the same thing if we had done 1 plus 2 is 3, and 1 plus 3 is 4. Now I'm not going to do this for the other two coordinates, but trust me that it works out. So this is essentially section 9-2. Every translation works the same. If we had -2 and -3, we would move this coordinate down 2 and to the left 1, 2, 3, and so that coordinate would be A prime. And for B, we move down 1, 2, and 1, 2, 3, and so forth. Now we're not going to do that. I trust that you guys have the ability to do so. So pause the video and you attempt to do number 1 and 2, and then we'll get started on rotations. All right, so when we talk about rotations, we're talking about rotating a geometric figure counterclockwise through the origin 90 degrees, 180 degrees, or 270 degrees. So when we say counterclockwise, we mean we're going this direction. It's just like we named the quadrants 1, 2, 3, and 4. So we're gonna rotate in the direction, the opposite direction than we typically would think. So say we have the figure, that's A, we'll say that is B, and this coordinate is C. All right, so we get this triangle. So we want to rotate this 90 degrees to the left. So when we say 90 degrees, what we mean is that there's going to be a line where if we draw an angle from like point A to this rotated point, it should make a 90 degree angle. So you guys should know, or maybe remember from algebra, that perpendicular lines have negative reciprocal slopes. And since we're rotating about the origin, it's easy to find that. So for point A, if we look at the slope from this point, from the origin to this point, we go up 1, 2, and over 1, 2, 3. So that would mean that the slope is 2/3 to point A. And so if we want to draw a point that's rotated 90 degrees from the origin, we need to do the negative reciprocal of 2/3, which is -3/2. So the slope of the line perpendicular is -3/2. Oh, can't see it. So -3/2. So that means that we could go from here, we would go down 1, 2, 3, and over 2. So we actually end up at that point, because remember, we want to go to the origin. So this coordinate is -2, +3. That would be kind of time consuming to do that for like a hexagon or something that had a lot of points. Now, so the easier way is look at the coordinate for x and y for the original point was over 3 and up 2. Now, if we look at this coordinate and compare it to that coordinate, it seems like the x and y flipped and the sign of the new x changed. So if we go back and redo this, we'll take this out. To get this new coordinate, the first thing we want to do is multiply the y coordinate by -1, which will give us -2, and then we flip the x and y. We flip the x coordinate and we get 3. So that's how we get our rotated points for 90 degrees when we rotate to the left 90 degrees. So that means that for A, we get -2, +3. Its coordinates right here. For B, B's coordinate is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So B's coordinate is 6. Oh, I'm sorry. Well, let's count that again. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So B's coordinate is 4, 6. So that means that when we write the coordinate for B prime, label it A prime. So B prime, its coordinate is going to be, remember, we multiply the y by -1 and make it the new x. So that would be -6. And then we switch the x coordinate and get 4. So that means we go over 1, 2, 3, 4, 5, 6, and up 1, 2, 3, 4, so that we have our new coordinate B prime. And then we do something similar for C. C's coordinate is 1, 2, 3, 4, 5, 6, 7, 8, 7, 7, 1, 2, 3, 4. So C's coordinate is 7, 4. So when we rotate for C prime, it's going to be -4, +7. So we go over 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. And it gives us C prime. So we connect these. And so, like, if we look at A, I'm going to take out the A prime and the A for a moment. If we draw a line to the origin, and then we draw another line from the origin to here, we see that we get a 90-degree angle between those 2 points. And then we could do the same thing for point B. If we draw a line to the origin, and then a line from the origin to the point, we have another 90-degree angle. So we can see that we rotated everything 90 degrees. So if you're looking for a rule, if we start out with a coordinate x, y, and we rotate 90 degrees, what happens is we get the opposite of the y coordinate becomes the new x coordinate, and the original x coordinate becomes the y coordinate. That's a 90-degree rotation.